Hello, Gen Chem friends. I hope you're doing well today. So welcome to the first chapter of Unit 2, specifically Chapter 4. And this chapter is going to be all about chemical reactions, specifically types of chemical reactions, and then doing more stoichiometry calculations, but specifically with regards to reactions that happen in solution. So in this first little video, we're going to do a brief overview of the types of chemical reactions that we will talk about in the course, and further videos, further mini lectures will dive more deeply into the details of those reactions. But let's first start with just sort of an overview of the types of chemical equations that you will experience based on their chemistry, what's actually happening in the reaction. Many chemical reactions are simple combination reactions where you take two simple substances, like in this case, gaseous nitrogen and gaseous hydrogen, and you combine them to form a more complex product, in this case, NH3. So combination reactions, you can think about it simply as A plus B to give you AB. Decomposition reactions are the reverse of combination reactions. You take a complex substance, AB, or in this case, calcium carbonate, or KClO3, and break it down into its simpler substances. So you think about decomposition reactions, taking something that's complex, breaking it down into two or more simpler substances. Most but not all decomposition reactions you'll see when they are written by the arrow, you'll see this little triangle. That doesn't mean changing, that means heat. Heat is sometimes required in decomposition reactions to break apart that molecule. So if you see that little delta above an arrow with a decomposition reaction, that just means that heat is required for that reaction to occur. So combination reactions, simpler substances coming together to form a more complex substance. Decomposition reaction, complex substance breaking down to give you simpler substances. We can also talk about chemical reactions as combustion reactions if they involve oxygen as a reactant. And most combustion reactions, if you think about like the combustion in a jet engine or the combustion with a Bic lighter, those reactions usually involve heat and or light. So these two reactions that I have down here under combustion reactions, they are combustion reactions because they involve reaction with oxygen. But combustion reactions can also be classified, at least these two combustion reactions could also be classified as combination reactions. You have two simpler substances coming together to form something more complex. So I mention that because many times chemical reactions can be classified in more than one way. These first two chemical reactions that are combustion reactions can also be classified as combination reactions. Another example of combustion reactions occurs when you have oxygen with molecules that have carbon and hydrogen, specifically hydrocarbons. Now that combustion reaction is not a combination reaction because we're getting CO2 and water from two products. But many times combustion reactions involve hydrocarbons. You'll talk a lot about hydrocarbons and combustion reactions if you go on in chemistry, specifically organic chemistry. So that's the third type of chemical reaction that we will talk about more in this course, combustion reactions. Those are reactions that involve oxygen and produce heat and light. We also have displacement reactions. Displacement reactions come in two flavors, single and double displacement. So in a single displacement reaction, typically you have some ionic compound, generically shown here as AB, some ionic compound reacting with some other species, typically a metal or some molecular species. And in that single displacement reaction, you see a switching of one species with the other. So if I was to have some ionic molecule reacting with some species X, X and A would switch places to give me XB plus A. Or a more concrete example would be if I had copper solid reacting with silver nitrate. When that chemical reaction occurs, a displacement occurs where the copper, that X, kicks out or takes the place of the silver to give me silver and copper 2 nitrate. So I like to think about single displacement reactions as one switch of partners, one molecular fragment, as I say here, is exchanged for another. In double displacement reactions, everybody switches partners. So in a double displacement reaction, which is also called metathesis, you typically have two ionic compounds, in this case shown generically as AB plus XY. If you remember ionic compounds, they have cations, positive charge, and anions, negative charge. In a double displacement reaction, the cation from one species pairs with the anion, or the negative charge, from the second species. So we can generically say AB plus XY gives you AY plus XB. So those double displacement reactions, also called metathesis reactions, everybody switches partners in those types of reactions. And double displacement reactions, we're going to spend a lot of time in future videos and future lectures talking about them, because double displacement reactions can be further subdivided or further classified based upon the kind of product that is formed. Many double displacement reactions are also precipitation reactions. Precipitation reactions, the hallmark of a precipitation reaction is the formation of an insoluble compound, specifically a solid. So for example, with this lead 2 nitrate and potassium sulfate, my products, which we will learn how to predict later, a little bit later on, my two products, potassium nitrate and lead 2 sulfate, this double displacement reaction is also a precipitation reaction because one of my products, specifically the lead 2 sulfate, is insoluble or a solid. We'll talk later in the chapter about how we determine what ionic compounds are soluble or insoluble. But those double displacement reactions that produce a product that is a solid or is insoluble, those are precipitation reactions. Acid-base reactions, those are also double displacement reactions, but specifically ones that involve, obviously, an acid and a base. And we've already talked a little bit about acids in Unit 1. We said acids were those species that had a hydrogen at the beginning, and an aqueous solution broke apart to give you hydrogen ion. We'll talk about bases later on in the chapter. But specifically acid-base reactions, those are double displacement because the cation of one pairs with the anion of the other. The acid-base reactions we will talk about in this course always give you water and some sort of ionic compound or salt as a product. So acid-base reactions, those can also be classified as double displacement reactions. And then the third type of double displacement reaction involves those reactions that produce a gas. So they are called gas-forming reactions. And typically they are reactions that occur between acids, like hydrochloric acid, and some ionic compound. So that is a summary of the types of chemical reactions that we will study more fully in this chapter. And that's the end of this little vignette. In the next video, we will sort of practice our skills of the definitions of these kinds of reactions to classify different ones based upon single, double displacement, precipitation, acid base, or gas forming.